The first problem asks us to find the measure of CDE, and that's right here. So it's a good idea to mark what you're looking for. So if that's CDE, let's see, what else do we know about this drawing? Well, we know that since this is 90 degrees right here, by definition, this has to be 90 degrees. We also know that because these are vertical angles, this has to be 20 degrees over here, and that means that this arc is 20 degrees. And so the measure of angle CDE is the sum of those two. It's equal to 90 degrees plus 20 degrees, and that's equal to 110 degrees. There are several ways to do this problem. We're actually asked to find the length of BD. And there's a way to do this that doesn't require much circle knowledge at all. We know that from here to here is the radius. We know that from here to here is also the radius. This is 9, this is 8, so this has to be 17, and we know that this is a right angle. And that means we actually have two congruent right triangles where a squared plus b squared is equal to c squared, which is actually 8 squared plus b squared is equal to 17 squared. So 64 plus b squared is equal to 289. B squared is equal to 225. B is equal to 15. So this is 15, this is 15 over here, and that makes this 30. Also, as long as we're doing this, it pays to notice 8, 15, 17 is a Pythagorean triple. Now, if you ever see a problem with those numbers again, maybe you'll remember. The problem here is to find the area of the sector DEF. Since this is 60 degrees here, this is the center of the circle. By definition, this is also 60 degrees. All the way around is 360 degrees. So we're not being asked to find the whole circle's area. We're just being asked to find that portion of the circle that is 60 over 360 degrees. The area of the whole circle is pi r squared. In this case, pi times 3 squared. And if we do a little bit of arithmetic fairly quickly, that's equal to 3 over 2 pi. And so that's the area. For this one, you're asked to find the length of JK, and this is a similar problem, except that instead of finding area, we're finding arc length. And arc length is a portion of the circumference. The radius is 6, and the arc length here is going to be this portion of 360 degrees of the entire circumference. So doing a little bit of quick work here, this will reduce. That will reduce even further. We can put 3 into both of these. Okay, so that's 24 over 10 pi. And we can go two ways with that. We can either say it's 2.4 pi, or if you went the other way with it, it's 12 over 5 pi. Also correct. Or you're being asked to find the measure of angle LPO, which is this. If we want to find the measure of this angle, we could get it by finding the measure of this angle because they are vertical angles, so they have to be congruent. This angle here is part of a triangle, so we could use the triangle angle sum theorem if we knew what this angle was. And in fact, we do, because we know that this is 30 degrees right here, which means that this has to be 15 degrees because it is an inscribed angle intercepting an arc, and it has to be half the measure of the arc. If we take 180 and subtract 40 and then subtract 15, 125 degrees, so that means this is 125 degrees, and the value of, or the measure of, angle LPO is 125 degrees. Looking at this one, we're asked to find the measure of angle RSP. And this is what we're being asked to find. That this angle is an inscribed angle that intercepts this arc. So whatever this is going to be half of it. The whole circle is 360 degrees. That's 150 degrees. That means this is equal to 360 minus 150, which is equal to 210 degrees. This is equal to 105 degrees, and that's what we were asked for. So that's 105 degrees. Find the measure of angle NKL. NKL is here. We already know that that is 58.5 degrees. We know that this right here has to be 187 over 2 degrees. And we know that these three angles here have to add up to 180 degrees. This is 93.5 degrees. These two together are equal to 152 degrees. And if I take 180 and subtract 152, I get 28 degrees. So this here has to be 28 degrees, and that's our answer. This one here, find the measure of angle LKA. Okay, so that's up here. And the truth is, that's the same angle as this one. Whatever this angle is, this arc here, the measure of this arc, and the measure of this arc over here, if we call this A degrees, we call this B degrees, and we call this X degrees, we know that X is equal to B minus A over 2. We also know that these two aren't congruent, but these two angles are. So it's 100 plus A over 2. Well, we can cross multiply and subtract 100 from both sides. And that makes this 60 degrees. And since we already know this is 130 degrees, we now have the information we need to find X, which is 70 degrees over 2, which is 35 degrees. So the measure of angle LKA is 35 degrees. Here we're asked to find the value of X, where X is this angle right here. Same as before, we know that we've got these two arcs here and here. And because this is 130, this has to be 230 degrees. We also know that X is equal to 230 minus 130 over 2, which is 50 degrees. So the value of X, 50 degrees. On this particular problem, we're asked to find KL, which is this distance from here to here. So we'll call that X. And what we know from looking at this is that the distance from here to here is 12. Okay. One piece of information left out here, we also know that this is 4, which means we know that the length from here to here is equal to 10. Now, the way these things work, if you take the outside length and multiply it by the whole thing, and here the outside length is 6, so if you take the outside length, which is 6, and multiply it by 10, that's going to equal the outside length here times the whole length. Now, in this case, the whole length is 12, but the outside length here is 12 minus x. So, if we take 12 minus x, multiply it by 12, what happens? Well, first of all, we can divide both sides by 6. That makes it 10 is equal to 12 minus x times 2. We can divide both sides by 2. 5 is equal to 12 minus x. We can add x to both sides and subtract 5 from both sides. And that makes this distance here equal to 7. This distance over here is equal to 5. This is the one we care about. KL is equal to 7. So here we're trying to find the length of BD, which goes from here all the way to here. And this is another one of those problems where the outside segment times the whole segment here is equal to the outside segment times the whole segment. So, what have we got? 4 is the outside segment, and 4 is the whole segment. So 4 times 4 is equal to the outside segment, which is 2, times the whole segment, which is this 2 plus this x over here. So 2 plus x. So we'll do a little algebra here. 4 times 4 is 16. And this is 2 times 2 plus x. We can divide both sides by 2 here. Make this 8 is equal to 2 plus x. And the truth is, that's really what we want. Obviously, x is 6, but we don't care about x. We want to know what this is, 2 plus x. So the length of BD is equal to 8. This is 6, but from here to here is 6 plus 2, and that's equal to 8. All right, for number 14, find the length of AL. All right, that's from here to here. Now, the way this problem was actually written, it's about some kind of ancient statues forming a circle, or a portion of a circle. Here's the way to look at this. We know, because this is a right angle, and we're looking for a diameter which goes through the center, that this has to be equal to this. And we also know that if we take this segment here and multiply it by this segment here, it will be equal to this segment here multiplied by this segment here. Now, one more piece of information that was in the problem. The distance from here to here is 12 meters. Right? That means that this is 6 meters and this is 6 meters. And this is some amount x. And so now we know that 6 times 6 is equal to 3 times x. We divide both sides by 3. 2 times 6 is equal to x. So x is equal to 12. What we really want is the distance from here to here, so that's 12 plus 3, and that's 15 meters.